Hi guys, welcome to my channel. Today we are going to see the first program in machine learning. In this, we are trying to understand how the data is distributed with the help of histogram. Along with that, we are trying to find the outliers with the help of boxplot. Okay. Now, if you want to see how the histogram looks, okay, I'm just scrolling down. So if you see here, this is called as histogram. Okay. Through this diagram, we are able to understand for the each interval how the data is distributed, in which interval the data is high or dense and which all the interval data is low or less dense. Okay. Through this we understand data density as well as data distribution. Now if you come down, there is one more graph called as box plot. Through this we understand outliers. So what is outlier? Very simple. There is a box. Okay, if this is a box and in this box there is a one side lower end, one side is higher end. Any values falls within this range, this will be accepted. Beyond this, whatever the values that are falling, right, this side or this side, both are called as outliers. Okay, so we are trying to find these outliers. Okay, why and what is the impact of that we will see through this program. Okay, so these are our main objectives of this program. Now to do this we need some Python libraries. So these are the four lines representing Python library which are we are going to import. In this, first two libraries representing the maths related libraries and remaining two related are graphs related. Okay, in this, first one represents the Pandas library. It helps you to convert the data into tabular columns. Okay, this is the work of Pandas. What is NumPy is doing? Once you create a table, inside if you are doing any mathematical operations like finding the average, mean, or both are same, mode as well as median, like this, any mathematical calculations you want to do, for that we are using NumPy libraries. Okay, after that one is Seaborn and one is Matplotlib used for drawing the graphs. In that, Matplotlib is the fundamental graph drawing library. It is used for all the basic plots. Okay, in that, above this we use generally Seaborn. Okay, Seaborn is almost using as a top on the Matplotlib to make this Matplotlib graphs more beautiful. Okay, more beautiful. For that reason we are using Seaborn. Okay, these are the four libraries. Now, so along with these libraries, I also need one more important thing, that is data, right? So here we are using California housing data from the scikit-learn library dataset. So I have libraries as well I have data set. Okay, this is my first fundamental requirement and that is fulfilled through this line of code. Now if I go down in this step, this is called as first step. What exactly this line is doing? It is just whatever the data set data is there, right, that I am bringing into the data variable. From that I am making into the frames. Okay, I am converting the data which is available into the frames. Okay, you can call it as tables with the rows and columns. Okay, this is what this first line is doing. After you make it as true, it will convert into the frames. Now housing.df is there, right? This is the variable it is storing the frame set data. What is next step is doing? In the next step, from the housing.df data, it consists some columns with the numbers and some columns with the text. For example, if any column has housing price, then it will be in terms of numbers. For example, 5 lakh, 10 lakh, like this house price will be represented in numbers. Along with that, some locations, or for example some column name is location, then it will be generally a city name. For example, Las Vegas, or from any country in India you can take it as Delhi, this kind of things. So one column consists of numbers, or some column consists numbers, some column consists text. Out of this, if you want to draw the graphs like this, you only need numbers or numerical features. You don't need text features. So I want to extract only numerical features from the entire table. That is what the second line is doing. For example, if you see here, from the housing.df, I am choosing the data types which consist only numbers. Those columns I am selecting and I am storing into the numerical futures variable. Okay, this is my second step, right? Now let us come to the third step. In this, now I want to draw the chart. Now you can see here the first line is telling that PLT dot figure is with the figure size telling that 15 cross 10. What this means? So in this 15 cross 10 represent the entire plot area. Okay, forgive me for this weird diagramming. So I am representing this like this. Okay, it is telling the first word is telling the width, second is telling the height. It means this is the width and this is the height. Width is 15, this one is height. What it represents with the units? It is generally inches. Okay, so in this plot inside I am trying to plot one more subplot. Okay, you remember this one. Okay, now I am using for loop. In that I want to draw, for example, whatever the numerical future is column is there na, in that if you see this diagram there are totally 9 graphs. It means there are 9 columns which have numbers. That is what indicates. Now I want to plot all the columns and I want to see how the data is distributed. That is the reason I am plotting one figure that is outside with the 15 and 10. Inside that I am using for loop. So each column has to come inside and sit as its own data. For that I am using 3 cross 3 matrix. Okay, so there are 3 rows. You can see 1, 2, 3 and there are 3 columns, right? So that is the reason 3 represent the row, it represents the column. Now I am using for loop. In that every future has to come from numerical futures table. From this each time one future will come and it will be storing into this place. Now how it is working? For example, there are 9 columns means I am going to write here. Okay, for example, there is a one column name with the medium income. One more column name is the distribution of house age, right? Third one is average rooms, like this. You assume that there are 9 columns. In this I is generally using indicating I is equal to 0, I is equal to 1, I is equal to 2. Okay, now here I is equal to 0 means the first column, but in this plot if you are trying to draw, index should not start from 0, it has to start from, this is 1, this is 2, this is 3. For that I am using here I plus 1. Okay, now I am using a for loop I. In that from all the 9 columns, each time, because for loop is working for each time only one column, in that future will consist for I is equal to 0, I is equal to 0, first column will come, I is equal to 1, second will come, like this each one will come, and for that I am drawing the histogram plot. In this I am using KD is equal to true means I am making the graph smooth. You can see some smooth line going over the bars. It is representing the KD. Okay, next bins is equal to 30 means it is representing the interval. Okay, for example, it is breaking the entire data set into the 30 30 30 intervals and I am using the color blue. Okay, now plot title, whatever the graph is coming above that I am writing like distribution of some future name is there, right? For example, first future name is medium income, that is coming as a title. Next time new thing will come, it will be storing as a new column name with the new table title name. Now it is dynamically taking the future name and giving on this graphs. So tight layout, next line is tight layout. It is representing that no graphs should merge or come one after like overlap, right? It should avoid the overlap. For that reason I am using tight layout. At the end I am trying to plot. This is all about the histogram plot and its code. I hope you understood. Now through this diagram you are able to understand how the data is distributed. For example, if you see distribution of medium income, now you can see that at the center of the point there are many people which have their income which is high, and the higher it goes the income is decreasing. Along with that you can see the average rooms. You can see that out of this there are many rooms which are falls between the less than 2 to 3 average rooms. This is the reason it is showing here, which is very narrow bar. Like this, you can see there is how the data is distributed and understand the nature. If you see directly to Excel, you cannot understand what is happening inside the data. For that reason, we generally use histogram. Okay. Now we will see box plot. So what is the reason why we need box plot? The reason is to find the outliers. Now what is outlier? Let us understand with this example. It is odd man in the group. Now for example, if you see some students got the marks within this range, okay, assume that these are the range where the students got the marks. Now someone marks which is we entered as a 200. Now it is called as odds man in the group. This 200 should not be there in the range. Okay. Now to find these kind of odds data, right, we generally draw the box, and whichever the value falls within this box called as accepted values, and any values falls beyond this box, right, here or here, called as outliers. Now to do this, we use generally formula called as, here I am writing, first formula is IQR, interquartile range. It will take the Q3 and Q1. What is Q3 and Q1? See here, Q3 is 75% of the data, Q1 is 25% of the data, and if you do the difference, you will get around 50% of the data, that is called as IQR. Let us understand with the example. Now if you take this data, what is the Q1, or 25% of the data will fall. It may fall, for example, let us break the full data into the 50% now. Okay, where the center point will come, it is showing that 32.5. Let us make this point here. Okay, this is our 32.5. Okay, this is center point. From this, I want 25% left side, 25% right side. Okay, that is 25% left side is called as Q1, 25% right side is called as Q3, and this is Q2. Okay, generally. Now Q3 is representing the 75% of the data. How it is calculating? It is taking the median of the first hop. Means if you consider these values are first hop, in this what is the center value, that we calculate using the formula. Consider 10, 20, 25, 30. This is the first hop. In this, center value is like 20 and 25 divided by this value. So 22.5 somewhere comes here. This is my Q1. Now what is the Q3? It is 75% of the data. It means second half, whatever there, right, total 4 values are there. In this, the half value. Now you may ask why I am doing average of only these two, why not these 4? So I am calculating the median. What median will do? It will take the center value. Now there is no center value because there is a left side 2 values are there, right side 2 values are there. To get the center value, I need to focus on these two, and from that I want to find the average. Okay, that is the reason I got this one. Now my Q3 is also available. Now if I do what is interquartile range, this gap is called as interquartile range, IQR. The formula is Q3 minus Q1. I got the 20 now. Now what I will do, IQR means, now I want to set the lower side one threshold and upper side one threshold. Above, below, those values called as outliers. Now to find the lower bound, I am going the Q1. I am staying here in the Q1 place. From that I will go left side, minus 1.5 times IQR. Means IQR is 20, means 20 into 1.5 times I will go this side. I will write one chart, or else let me remove this. Okay, so one second, it is going all over. Okay, I am removing this. Now I will draw the red. Okay, now from here I am drawing 1.5 times IQR in the left side. It will come somewhere here, assume, and in the right side also I am drawing somewhere here come. Okay, because 200 I already wrote, right? So it will come somewhere here, that is like, see, 72.5 is upper range somewhere here, and the lower range is minus 7.5. So if anyone gives any values below this somewhere and above this somewhere, called as outliers. I don't need these values. It will affect my accepted range values within this range. Okay, that is the reason I want to find these outliers with the help of code. I hope you understood. Okay, outliers. Now you can see the graphs. You can see the box plot is there. Outside there are some dots values are there. These are called as outliers. Now how to find? For this, let us remove or erase this for better explanation. So to do that, now what I will do, now I will come here see the first line. Now I want to draw the graph. Again guys, you can see here I am drawing the big plot with the 15 cross 10, right? This is my big plot 15 cross 10. And again I am not going to explain the same thing, 15 cross 10. Inside again I need 9 graphs individually. For that I am using the for loop. In that I is going from starting first place to till last plate, and each time it is going, it's taking the numerical feature, and each time it is giving one feature and 3 cross 3 matrix. You can see here this is 3 rows, 1 2 3, and this is 3 columns, and each time it is storing into the 1 1 position. So I will start from 0, it will go till 8 because there are 9 columns with the numerical values. Starting is 0, that is the reason I am using +1 here to store each places. So it will go till 9 places and store all the box plots. Now color is orange. Again I am using box plot, and each time it is taking the dynamical titles and tight layout with the show. Same like above. Now this graph is plotted now. Still the condition for the outliers not yet written. For that we will come down. How to identify the outliers? For that first I am trying to print some like message outlier detection so that the code will be easy to understand for everyone. Now along with that, outlier summary is there, means how many outliers are present in that it is showing. Now to find how that elements or how the outliers came, first see here as I explained Q1 Q3, here I am using for loop. For each feature it is going to calculate Q1 Q3. How? Housing.df has each feature numerical feature. For that I am taking Q1 is 25% of the data, Q3 is 75% of the data, IQR is nothing but Q3 minus Q1. I did here, right? I hope you understood, right? From the box plot I draw already. From here I draw, this is Q1, this is Q3, somewhere I wrote, okay? This gap is called IQR. Now lower band is calculated using with the help of Q1, and it is going toward the negative side, that is the reason minus and 1.5 times IQR. Here the box with the some narrow line will come. Now above side also we are calculating the upper bound. For that also Q3, this side it is going toward the positive direction, that is the reason plus 1.5 IQR somewhere comes here, okay? Somewhere comes here, which is below to 200. Here I am writing the lower higher bound or upper bound, here is the lower bound. Within this everything is acceptable. Outside this called as outliers. Now understand the condition. Outlier is there, Hausen.df is there. Now from the Hausen.df, each feature if it is lesser than lower bound, it means any value it is lower bound, any value falling somewhere here assume, okay? Or else I will draw here, okay? This is a box plot, this is my lower and this is my upper bound. Now any value that is lower than this place, it is called as, and along with that I am using or, means either this condition will be true or this condition will be true. In any one case it will execute the answer as true. The next condition is Hausen.df feature should greater than upper bound, means somewhere falling here. If this any one condition satisfies, I am going to tell this as outliers, and I am printing the summary here, okay? That's it guys, nothing else is there in this code. I hope you understood. Now if you take this code and run in the Jupyter notebook, you will get the output in the same way. Now in the Jupyter notebook I have copied code in section wise. Now let us run one by one. If in any block if there is error, it will throw error guys, or else it will give the output, okay? Now I am running the first block. If I run, it will showing that there is no issue. Now number 1 is coming, right? It is showing that there is no issue. Now in the second box if I run, again you can see number is not assigned, and if I run, if everything goes well, yes, then it is working. Let us go for third block. Yeah, till now it is done. Now if I run this block, it will give number, along with that if all good it will give the plot or histogram plot, okay? Let us run. Yeah, you can see guys, now the histogram plot is showing. Now through this you understand how the data is distributed. Once this step is done, let us go for box plot for outlier detection. If I run, see guys, again it is showing the box plot, and you can see here there are dot lines are coming, right? These are called as outliers, but we want this in terms of numbers. For that I am going here, applying the formula and getting those outliers into the numbers. Let us run. See guys, it is showing how many outliers are present. In the above you saw through box plot, right? Now you are understanding through the numbers. Median income consists of 681 outliers and average occupation consists 711 outliers. Like this, there are many outliers are present. And at the last, if you see, you are able to see the summary, how the data is distributed with the help of mean, median, mode. Right? I hope you understood. Now, if you understood well, please comment me in the comment box that box plot or histogram or outlier, whatever, or else if you understood very well, you can comment in a better way so that I can understand. And if you have any feedback to give, please feel free to give. Okay? Meet you in the next program. Until bye bye and take care.